take a few minutes to, let's see, okay. So just wanted to take a few minutes to kind of give an introduction on, who I am, what my background is, so that you can understand where I'm coming from. I'm going to share, not only the cloud computing side of the business, how to get started on this one, what the market looks like, understand the technical concepts of it, and I'm kind of, I think, uniquely positioned because I started cloud computing training a long time ago when people are not even aware of these concepts. And I had made a couple of predictions back in 2012, I think, and I'll share those predictions, and we'll see how accurate those predictions were. And then we'll talk about why AWS and what are some of the services that AWS offers. And what we'll do is finally we'll look at one specific service, the RDS, the database service that Amazon has, and we'll do a little bit deeper dive into that topic. And finally, we'll leave some time for Q&A. So instead of giving me, where I worked and everything, I thought, let me just create a chart on my personal story and how I got started and how I ended up in the cloud computing thing. So I started my life or career as a Unix sysadmin, worked there for a long time, and then slowly somebody asked me to start managing the application. So I became an application admin, specifically AOL registration system, which is one of their most mission critical application. While doing that, I was asked, I did a good job in that one. So they asked me, can you, I was given a choice. Do you want to become a storage engineer or a security engineer? Then I became a storage architect because I really liked the manager and person, right? So I became, got a promotion, from an admin, I became an architect, got promotion. And then at some point I did such a good job in being a storage architect. My manager said, I want to promote you to be, I want to give you a promotion. Do you want to stay technical or do you want to stay manager? And I said, okay, I already know the technical aspect. Let me become a manager. So I became a tech manager, and within 3 months, I got laid off because everybody on the first level of management got laid off. And then like everybody else, this is back in 2007. And like, what next, right? So that's when I started looking into cloud computing. This is 2007 or 8 time frame. AWS was very, very early in that time frame. They didn't even have EBS storage, which is a very fundamental service now. And to give an example, if you start an AWS instance, you better not shut it down because everything was in, everything was in storage. The storage would just go away. So those were the days, early days. So became a cloud architect, and then I was promoted. I joined a company as a VP of cloud practice, and then eventually, I said, okay, I did it so many times. Then I founded my own cloud consulting company. So this is where I am right now. This has been my journey. It's 22 year worth of journey. And I want to tell you another personal story of my friend, Sergio. He and I started in the IT industry around the same time. And he was a database administrator, specifically MySQL database administrator. And he was not very outward looking. He was not future proofing his skills, right? So he became a DBA. He got promoted to senior MySQL DBA. We were working on what project. And then the manager was essentially asking, we want to get rid of 40 plus databases and go to cloud. And he was very reluctant to go with that plan. But somehow we kind of managed to migrate all the services because the CEO saw the writing on the wall. It is a small company, about 50 or 60 employees. And he saw the writing on the wall that cloud is the future. So we migrated everything to RDS. And then it sounds kind of harsh, but the day of the migration, the final migration, he was let go. And not because he was a bad employee or he was not going with the plan, none of that stuff. And we'll see shortly why this matters when we are talking about RDS. And he was let go because I could do that work myself, right? So that's what you'll see throughout this presentation is there are a lot of challenges for us in IT folks, and um, trying to find the ways on what to do next is very, very critical. So then he obviously became unemployed. So the moral of the story is, there's always changes coming in. We need to be aware of those changes. And then those are the circumstances, right? Look, like I said, in this case, the CEO wanted to go to cloud. He saw the writing on the wall, so he said, let's go to cloud. And we cannot blame the circumstances. We cannot blame the CEO in this case. It's our job to adapt. And that's the takeaway from Sergio's story. So I do a lot of, what do you say, not consulting, but career advice to a lot of people who on LinkedIn, or people who just randomly call me and then say, this is what I'm trying to do. Where do you see the opportunities? And these are like people who either just finished their education, or they are bored with their job, or they are in QA, or some other field, but they want to get into cloud computing. So my crystal ball says, like, if you had to choose a career right now, cloud computing, DevSecOps, security is good in the sense that it will provide you an employment for at least next 10 years, right? Oops. So that is the basis of all the other jobs that will be coming into the future right now. So we already know about the big data part; those are coming in. There are a lot of jobs around big data, machine learning, but cloud computing still forms the foundation of it. And then there's the additional step is the analytics piece, the data engineering piece, the robotics process automation. That's a huge field right now that's coming in. Again, these are all where I see the market going in the next 3-4 years, or maybe you're already there. And then if you want to stay on the pure development side, mobile computing, distributed programming, distributed databases, distributed applications is where you can differentiate yourself. Again, feel free to stop me and ask me any questions. I want to make it as interactive as possible, right? So just don't want to be a one-way street here. And you can obviously disagree with my predictions. So what are the prospects? People ask me, okay, what can I expect when I get into cloud computing? And we'll see some of the numbers and some of the charts. Again, not everything is, these are all not my numbers. These are the TechNets and the info ITs people, and this is what they are saying. And these are all fairly recent one. The cloud computing market, as you can see on the left-hand side, is growing exponentially. It's almost doubling every couple of years. As a cloud engineer, you can expect around 115,000. This is nationwide. Obviously, if you're on the coast, the salary is much higher. We'll see that in a second. And the number of jobs is increasing steadily. Every year, it's almost doubling the number of jobs that are in the cloud and DevSecOps area. So DevOps happens to be the second most sought out of job after data scientist, just so that you know. So this is the growth that we mentioned earlier. This is the cloud computing growth, not necessarily the jobs. As you can see, it's growing steadily from 2019 is when they started capturing it. And it's kind of doubling every couple of years. In the next 5 years, they're expecting to triple the size of the cloud computing market. So lots of opportunities, lots of things to do in the field. So this is something that I like to do once in a while. I go to Indeed.com, and there's a section called Job Trends, and I just say, okay, what is the number of jobs that are being posted for AWS? So what are the jobs for Azure? The one in the pink on the top is the AWS line, and that's the percentage increase every year on year on the left-hand side, and the purple one on the bottom is the Azure one. Still a healthy growth, but a lot of growth in the AWS side of the house. So this is also from Indeed.com. what I do is, this is the Bay Area, like I mentioned. If you're on the West Coast, these are the salaries that you can expect for cloud architects. Our average is about 150K on both the coast. Fortunately, the DC area is a little bit higher. Uh, I would say it's about the same thing as California, slightly higher in the DC area, I think, compared to Bay Area. But DC, New York, Boston, Seattle, those are the major areas for cloud computing jobs. So this is the prediction I said I made it in 2012, right? So the first prediction, I made two predictions. So within 5 years, that is by before 2017, every job will interact with cloud or big data one way or the other. Whether you are a network administrator, security administrator, programmer, it doesn't matter, right? So you will interact with cloud one way or the other. You just cannot stay away from it. And I think that prediction has come true completely. All right. So every job that you either are using it in cloud in the backend, or the job is not even possible without the cloud and big data technologies. So again, this was 2007, end of 2017. By 2022, I said only cloud providers will own and operate data centers. So if you are a small, medium-sized companies, even a large enterprise, even if you're a Fortune 500 company, you won't, if you need power, you don't build a power plant, you basically rent it. And that's where the market has gone. I think in the last 10 years, you are seeing there's a lot of consolidation in the data center. The reason people are used to go to colo has gone away. So AWS or Azure is the new data center for a lot of these agencies. Even large conservative agencies like FAA that we consult on occasionally, they are basically shutting down a lot of their data centers and moving to cloud. That's a 10-year plan that's already started. IBM is the lead on that one. So I thought that would be the last agency to go to cloud, but they started their journey a couple of years ago. And similarly, if you need server capacity, you're not going to build data centers. You're just going to go and rent it from a lot cheaper from these providers. So why is it matter? Why does it matter, right? Why do you need to know about cloud? Because cloud touches everything, whether you are managing servers or you are a database administrator, like we already mentioned Sergios case. If you're a storage administrator, you're networking, security, backups, everything that we do in IT has moved to cloud. Everything touches it. Even if you're doing software development, you are being called to do cloud native development now. If you're doing a product management, project management, that changes. How do you price your services? Instead of doing a one-time purchases, now you're doing subscription-based pricing. And even if you're just a pure developer, you're not just writing the software anymore. You're basically renting and integrating with third-party services. So as you can see, it basically touches every facet of IT. And that is the key reason that we need to understand this foundational technology. Any questions, guys? I don't want to keep talking. If I'm okay. Shane, please keep an eye on the chat window. I cannot see because the screen is full.
Sure, I am on it. I'll let you know if there are any questions. And
Sure.
I think the flow is good. And please, I'm enjoying this session.
Okay, yeah. If I'm going too fast or something, let me know. Be happy to slow down.
Sure thing.
Okay. So the job market, if you look in any, you open a job description, Indeed, Dice, anywhere, you see there's like 10, 15, 20 skills that they are asking you, right? So there's no pure play jobs anymore, in the sense that you cannot just say I'm a Java programmer anymore, right? So they want to have a full stack engineer, even if you're just a developer, right? So they want to make sure that you understand security, you understand, front end development, back end development, ability to work with the cloud, right? So, testing, this tool, that tool. I mean, like, there is no pure play jobs anymore. You cannot go and sell yourself as a C programmer or a .NET administrator. It doesn't work that way. If you are a Unix administrator, your jobs are being eliminated. If you are a pure database administrator, your jobs are eliminated. If you're not touching these emerging technologies, either you're getting eliminated or the number of jobs that are available to you is kind of reducing. So now my recommendation is to become a generalist, right? So wear multiple hats, do multiple projects, learn the ability to learn these skills quickly at the last minute, right? So that is the key part, that these things will keep on increasing. The number of skills that you are expected to know keeps on increasing. That's the reason my recommendation is to understand and know what core skills are required for your job, right? Whether even if you are a database administrator, understand what are the core skills and then tack on the emerging technologies. And speaking of databases specifically, we'll talk about what are the core skills a DBA needs to know, what are the core skills a cloud engineer needs to know, and then add on the emerging technologies, because that is the key to survival in this today's market. Yeah. So why does companies love cloud? It's easy to scale. Obviously, you can overnight, the level playing field has, is kind of same now, whether you're Facebook or mom and pop shops in somebody's basement, you have access to the same cloud that they have, right? So you can set up your services. There's no upfront cost. That's the reason, one of the reasons that you're seeing there is so many startups are coming, because they can offer the services very quickly. They can just set up a service, because you won't believe it, I'm consulting with a company in California. The idea was conceived in January of this year during the pandemic, and April, they had a beta release, and July they released the product to the world. And it's a very, very complex product. It's not something like you go to a website and do something. It goes into their clients' ERP systems, it automates it, and it does a lot of things on the back end. And the entire thing was completed in 3 weeks because of cloud computing. Right? Imagine getting this installing in a traditional colo and everything, they would still be fighting for that one. So a lot of companies are being able to go because of this model. And large enterprises, as you know, they have two types of expenses. They have capital expenditure and operational expenditure. Capital expenditure is expensive because they have to spread the cost across multiple years, amortize their cost, right? So if you buy a server, IRS is not going to let you take deduction on that server on year one, because the life of that server is, let's just say, 5 years. So if you buy a $10,000 server, you can only take $2,000 every year. But if you give $10,000 to a consultant, that expense is immediately tax deductible, right? So that's where a lot of companies want to go to OpEx, because AWS costs are considered, OpEx, because they are operational expenditures. It gives them true elasticity. They can grow and shrink. When we're talking about scaling, we only talk about increasing the capacity, but it's also important as us to even shrink the capacity. When we don't need it, we can shrink it, and cloud allows you to do that. And then this is the critical piece: is we are not building data centers, we are not setting up servers, we are not installing antivirus software, we are not wasting our time in doing undifferentiated work. All that heavy lifting of managing it, securing it, everything is done by the specialist. We are just writing the application and pushing it to the cloud, right? So that's what makes it time to market is very quick, because you're not doing a lot of this undifferentiated work. So we may or may not realize we're already in cloud. Everything that, even if you use a simple smartphone, your laptop, everything, your Gmail, your blogs, your Facebook, everything is already in cloud. All we have at the edge is essentially windows into this cloud, right? Not a lot of things get stored on your laptops or phone anymore, because everything is in the cloud. So we've been using this for several years. Now our goal is to get into this cloud and see how they do it. Right, so that's basically where our job is, to understand, get into this blue cloud, and then figure out how to actually create some of these services ourselves. Okay, so shifting gears, when you say cloud, again, a lot of this is very textbook definition. It's good to have this knowledge, but in practice, it really doesn't matter, right? So if you, this definition comes from NIST, National Institute of Standards and Technology, Maryland-based company, agency, government agency that kind of define how the cloud should look like. What are the different categories? So the main categories they started with was IaaS, infrastructure as a service. When you're just hosting it, you're just getting the hardware. Platform as a service, when you write the software and just give it to the cloud provider to run it for you. And then the SaaS, which is Gmail or your Yahoo Mail, is a software as a service. You're not installing the software, you're not managing it, you are basically consuming it, basically. Like I said, it's very difficult to pin down one company in any of these buckets, right? As you can probably, even adding a service in one of these categories is very difficult, right? But it's just good to understand what they mean at a very, very high level. And I'll show you one more diagram where you can go a little bit deeper. But this is mostly theoretical at this point. So I won't spend too much time understanding this, as long as you're familiar with the terminology. So this is a little bit, goes into the detail, right? So if you look in the left-hand side, this is what we used to do pre-cloud days, right? So everything in blue, we managed, the customer managed it, the infrastructure, the platform, operating system, database, data, networking, storage, everything we used to manage it. So when infrastructure as a service came along, everything in orange is managed by the provider, the vendor. In this case, let's just say Amazon. Everything in blue, we still manage it as a customer. We select which operating system you want, what stacks do you want, what databases do you want, and obviously you write your own application. And as you move to the right, the operating system, the middleware, the runtime is all still managed by the PaaS vendor, platform as a service vendor, and you just bring your application and the data. So your level of effort is going down while they are doing a lot of the work, heavy lifting for you. In this case, they're essentially providing you a Java platform, a PHP platform, or whatever, Ruby, Go, doesn't matter. And you're just bringing your application and data, and you don't care whether they are using Dell hardware or whether they are using Linux machine or Windows. It really doesn't matter to you. You are essentially consuming everything, and it becomes, your job is a lot more easier. And obviously in the final one, the software as a service, you are not doing anything. The application is theirs, the data is theirs. You're just consuming that service for you. So that is where the market is. Obviously, the more SaaS solutions that you can offer, then it's easy for your consumers to consume it, right? So the market is shifting to the right. And obviously you can start, a lot more bucks if you offer a SaaS service as opposed to a PaaS service. Okay. So this is another way of slicing the same information, like, deployment models is what they call. Where does it get deployed? Who manages it? Those are the questions, right? So public cloud, obviously, the AWS, the GCP, and Azure, the large cloud providers, they are all offsite. It's all managed by a third party. You're just using it. In the hybrid model, you have some components in your own data center, and you are basically attaching your internal data center to the public cloud using some sort of connection between these two, and then that's how you consume the public cloud. The private is obviously you manage everything. You essentially replicate the AWS or something by using something like a VMware or OpenStack or any of the other open source tools to kind of create your own cloud offering. Obviously, this is not in fashion anymore. People are either they want to go to public cloud or hybrid cloud, but there is an option to use a private option as well. Okay. So this is the original NIST model that we talked about. It kind of summarizes everything we discussed in the last 4 or 5 slides. We have the deployment models, the public cloud, the private cloud, and the hybrid cloud. And there are certain community clouds, like cloud that's meant only for financial institution or government agencies, right? A Gov cloud, for example. So those are all deployment models. Then you have service model, whether SaaS, PaaS, and IaaS, which we talked about. And the essential characteristics, this is the NIST definition. So every cloud provider should provide these 5 essential characteristics. So broad network access means you are consuming the service over a network. In other words, if you are using AWS service, you are not in their network. You are consuming from your own laptop, right? Rapid elasticity means you can grow and shrink the service as and when you need it. Measured service or pay as you go means you are basically paying for service however, whatever you're using, you're paying for it. So it just is like just like a taxi, right? So if you're going from point A to point B, you don't care what kind of car it is, what kind of service he is doing, none of the stuff. You basically get on at point A and get out of point B. You just pay by the distance. This is exactly the same way, right? You're just paying for the measured service. If you use the instance for 3 days, you're just paying for 3 days, and that's it. On-demand service, self-service means you don't have to call anybody to get the service. You don't have to open a ticket, none of the stuff. You just can click a button and you get the service. And finally, the resource pooling means the service provider, in this case Amazon, kind of pools all the requirements into one umbrella and slices the service for you. So it's all economies of cost, right? So the more services he can pool, the better or lower the cost would be. So any questions, guys, or making sense? Okay. So I love to talk. I'll keep on talking until somebody stops me. So just a warning. Yeah, but if I'm going too fast, feel free to ask me to slow down or repeat anything. So we keep talking about AWS. Why AWS? They are Amazon Web Services, or AWS as they're called, is the largest IaaS, SaaS, PaaS. They do it all, right? They own more than 80% of the market share. Their service, again, I'm not an AWS employee. I don't get money to pay, to do their advertising or anything like that. I'm just a happy customer. I'm not even their reseller or anything like that. Their documentation is a lot better. The using their service is a lot more easier. It's very mature. Their service is very mature compared to their competitors. And a lot of the competitors that I find, especially Azure, they're just trying to either catch up with Amazon or trying to correct some of the mistakes that AWS did, right? Because when AWS started, there was nothing to compare with. So they made some mistakes, I would say a lot of mistakes, but a lot of these providers like Azure, they are correcting those mistakes. We can talk about what those mistakes are on some other day, but the bottom line is, in terms of the number of services and the maturity, AWS leads the pack. So this is every year the cloud industry kind of waits for this magic quadrant. It's put by Gartner, and what they do is they kind of have 4 quadrants where the leaders belong, where the challenges are, the niche players, and the visionaries, right? Based on last 7 or 8 years, I've been tracking this. I think forever, Amazon has always been the leader. Microsoft and Google are close by. IBM, HP's you don't even see in the chart right now. They've fallen. Rackspace was there. They're all gone out of the business. But that shows you where the leadership is coming from, the innovation is coming from. Again, they put it around January or February of every year, so you can find this on Gartner's website as well. So this is an interesting chart, not necessarily related to cloud, but the Amazon's focus is on the long term. So the blue line is the Amazon's revenue, right? So that's the total money they bring in. But you look at the yellow line on the bottom, that's their net income. So that means that's the total profit they are getting. And this is as of 2013. It's gone up slightly now. Their income has gone up slightly. But the bulk of the, okay, now you might be asking, okay, if they are making so much money, what are they doing with it? Right? So the short answer is they're reinvesting back into the business. Right? All this money that they are getting goes back into the improving the business. So that's where Amazon shines, is that they are in for the long run. This is another way of looking at it. Okay, this is another chart. So the blue one is Amazon's AWS portion of Amazon's revenue, and the orange one is their Amazon.com's total revenue. And as you can see, the revenue is steadily increasing. The blue bar is increasing. And I think by 2025, they're saying this will either be equivalent to the total AWS revenue, or it will dwarf the total revenue. So that's why Amazon AWS is such a huge component of Amazon's profitability. So let's leave the financing behind and let's get back into AWS. So if you look at a traditional stack, whether you're looking at data centers or cloud, they all follow the same model, right? So you have infrastructure on the bottom, your cables, your hardware. Then you have networking, that's connection, that router switches at the next layer. Then you have your servers, your storages, your storage arrays, your databases. Then you install your app services. Then you do the management. How do I deploy it? How do I create users? How do I go the logs? So this is our traditional model services that we've been using for a long time. And the reason I mentioned this is AWS essentially does almost everything in every layer, right? So if you look in the bottom, they have global infrastructure, which are the regions and AZs, or availability zones, that are spread across the globe. They have edge locations. This is their infrastructure or networking layer. They have the foundational services, your networking, databases, storage. They are called infrastructure as a service or foundational services. On top of that, they have application services. There are your PaaS, your SDKs, your search engines, your queue systems, your email systems, your content distribution. All those things are considered application services. And then they have the IAMs of the world, the how to monitor it, how to deploy it, how to secure it. All the application or the management is at the very top. So AWS is also kind of follows the same model that we saw earlier, right? So the takeaway from this slide is AWS has services in every layer or every part of your application stack that you want, right? You want monitoring, they have it. If you want automated deployment, they have it. Again, this chart is very old. It doesn't capture a lot of the services. This is probably 2015, I think, this slide. So now they have over 200 services. I cannot put that in one chart, right? So, but to give an idea, every layer is covered essentially. Okay. So let's switch gears. And how many of you are database engineers, or have you worked with databases in the past? Let me see if, I don't know if they have any. I don't see any questions, but okay. So let me go back to the presentation. So if you look in a typical database database, right? So what does a DBA do on a day-to-day basis? He obviously installs the database, he installs the patches and migrate from one database to another. He's responsible for creating the users, and deleting the users, giving him the access permission. He is kind of does the replication from master to master or master to slave. He copies the data from one environment to another environment. He monitors the health. He does the capacity planning. If there's any performance issues, he does the tuning on that one. There could be a lot of daily database jobs, backups or synchronizations or whatever, indexing. All those jobs need to get run every day. He keeps an eye on those. He does the backups and snapshots, all that. And then most of the time he's spending time in increasing or decreasing the space, right? Databases run out of space on a very regular basis. So these are, I mean, if you talk to a DBA or if you one of you are a DBA, you would know these are the typical things a database administrator does on a day-to-day basis. If you look at RDS, right, so a lot of the tasks that you saw earlier, I would say majority of them have been automated. AWS says, okay, don't worry about it. I will automate it, outsource it to me. So everything that you saw on the previous slide is gone. So if you are a database administrator on Amazon, they do the installation, upgrades, patching, replication. All that part has been automated. So that's the reason Sergio was let go, because of this chart that I'm showing you, right? Because now all you need is an application developer to design the application, to design the table, and he needs a cloud engineer like me to kind of focus on the some simple things like backups and replication. So there is no need for a database administrator, at least at his company, because a lot of the things are already done by Amazon for him. So he just pays one fee for the database, and he gets a lot of these services that we saw earlier for free. Right? See, so it's always human cost is a lot more higher than the software cost. So it's easy for him to just say, okay, I'll pay additional money for Amazon, if he can do this one. So then now you're asking, okay, if I'm a DBA and if Amazon is doing everything that you showed me, what am I supposed to be doing, right? So the answer is you focus on value-add services like NoSQL. You focus on data engineering, data warehouse, data lakes, data consistency, right? NoSQL adoption, how to generate the data, and how to data governance. There are a lot of things that Amazon cannot automate that you should be looking at. Data sharding, right? How to split the data between multiple databases, right? How to make sure that the data is consistent, whether it's encryption. Like a lot of those things that we could not do as a database administrator, now you can focus on, because a lot of the automated things have been automated for you, right? So that is just one service. I mean, like I said, there are 200 services that Amazon has, and all the services that you can see, have been automated to a lot of extents. That was the reason I was telling you earlier, the change is very critical. Okay. So let's deep dive. What is an RDS, right? RDS is relational database in the cloud, right? So Amazon hosts it, they manage it, they do the patching, upgrades, backups, everything they'll do for you out of the box, right? It's scalable, it's very, very cost efficient, and it's essentially in the back end, it's the same databases that you know and love, right? MySQL, Postgres, Aurora is a new one, but again, it's a MySQL variant. Oracle, SQL Server, all the databases that your DBAs know, your programs have been written to, will continue to work with RDS. The monitoring is done by them. The HA, replication, MultiEasy, all of those things are done for you. If you want to read-only databases for your reporting, for your backups, or for your, if some other team wants to read-only copy of the database, it just takes a fraction of a second to create a read-only database and give it to them. So a lot of these things are very easy in RDS, a lot of these things used to take weeks and months to set up, right? But now it's just a matter of minutes. So we'll look at a couple of useful features, right? Multi-easy deployment. What does it mean? So on the top, we have an application that could be, running on a server, EC2 instance, or any kind of Kubernetes or Docker, anything, doesn't matter. And you are writing on the left-hand side to the master database, the database that labeled M. So when you enable multi-easy, so every time you write to this master database, it synchronously on the back end copies it to a standby database in a different data center, right? The AZ is essentially Amazon's word for data center. So any data that's on this master gets copied over to the second database, seamlessly. You won't even know, right? And if, let's say, something happens to this master, it goes away, your application doesn't have to change anything. It just times out, and then Amazon automatically switches over to the standby database and your application can continue writing to the standby database as if nothing happened. You'll just have a small hiccup of few seconds, and then you're back in business. And while you're doing that, Amazon spins up another standby database. It makes this S as the master. It spins up another database somewhere in a different region, and then starts replicating to that. So you'll not lose, there is no loss, data loss at this time. So that is a critical piece for a lot of enterprises, is not to have any data loss. So in this scenario, you don't have any loss, because synchronous means when an application writes to this database, before it acknowledges that the write is written, it has to make sure that the data gets to this other database, right? So this is what synchronous means. Until the data reaches to the standby database, your application is not told that the data has been copied over. Data has been written to the disk. So every write goes there. So that's what the synchronous means. So read replica is another interesting feature they provide. So, and this one is asynchronous. So that means the application is told, hey, I wrote the database to the disk, but in the back end, it makes multiple copies of the database. So if you want a couple of copies of the database for backups or for reporting, or you just want to see some data for QA or whatever, you can give them their own version of database without impacting it, without impacting the master. And because this is a read-only database, obviously nobody can write to this database. Only this guy can write to it. And there is a slight possibility of data loss because the application has been told that the data made it, right? But then it takes few seconds to, this could be one or two writes behind it. That's all it means. And typically the way we use it is, if this is a web service, and if the web service obviously has, reads and writes to the database. So the red line that you see is the writes. So anytime the application needs to write to the database, that's the red line. It goes and writes into the master. But when it wants to read it, it can go to any of the copies. It can go to the master, but more likely it will go to any one of these read replicas. So that speeds up the read, because most of the time your application, the web service, is actually doing reads, right? So the read to write ratio is like 80% reads and 20% writes, or less than that. So you want to optimize the number of readers by creating these read replicas. So how do we scale it? Scaling is adding the storage, changing the instance type from a small instance to a large instance, changing the password, improving the speed, when to back up. All those things can be done from one screen, right? So remember, one of the tasks that I told the DBS has to do is increasing the data space. So I started this database with 5 gigabytes. I can go 10, 20, 30, or however I want to, just by click of a button. I just come in and do it and hit apply. It does automatically. And now the newer databases are even more efficient. You can tell them to add storage if it hits a threshold. If it says, okay, once I write 80% of the data, keep on adding more storage. So Amazon does it for you in the background automatically. Right? So those are some of the innovations that they bring to the table. The backups, right? So one of the major pain point for DBAs was the backup. When to backup, how many days to backup, do automatic backups, manual backups. All that stuff is just one click of a button. How many days do you want to backup? You can come here and select. By default, one is provided, but you can go up to 35 days. What time do you want to back up? If your application has a downtime, the number of users goes down, you can specify when to back up. The maintenance window is when to change, when to upgrade your database. Let's just say there is a minor version. So if you look in the previous screen, this one was 5.5.33. So if there's a 5.5.35 released by MySQL, you basically tell it, okay, during the maintenance window, you can upgrade it, right? So there's an option to say, okay, here, auto minor version upgrade. And by default is yes. So essentially you're saying is don't bother me if it's a minor version, okay, go and do it. But if it's a major version, if I'm going from 5.5 to 5.6, okay, don't do it. I'll do it manually, right? So when you're saying auto minor version upgrade, during the maintenance window, in this case, we are selected Tuesday 4/19 for 30 minutes, right? UTC time, it can go and do this 33 to 35 upgrade automatically. So that's what that means. So RDS feature summary, it's a completely managed database. And if there's a host fails, disk failure, something happens, it automatically gets replaced. There's no administration overhead. Like I said, you don't need an administrator now. Push button scaling, we just saw, you can increase the instance size, the disk size, memory size, whatever you want to do. You can add replicas. You can do a multi-easy automated synchronous replication. And the read replica was an asynchronous replication. They do automatic failover. And this one, we didn't talk about it, but if you want higher performance disk, right, you can use something called a provisioned IOPS, where you're saying, I'm doing a lot of writes, I want higher throughput. So in that case, you can go and configure something called a provision throughputs, provision IOPS. Let's see here. Here, you can say, this is the place where you say use provision IOPS. You can check the box and you can say, how many provision IOPS do you want? And there's an additional cost to that one. So you have to be careful. Okay. So what does it mean for me, right? So I'm doing software engineering, I'm doing project manager, I'm doing whatever, right? So I want to take a simple example of what we used to do when you want to put a database for provide a database to an application, right? So for simplicity's sake, I'm removed the application, but since database is the key part, my goal is now to take this database and give it to my customers. So in the old days, this is what used to happen. This is, when I say old, I mean pre-cloud days. So the support staff would get the server, they will give it to the networking team. The support staff would basically install the hardware, cable it. The networking team would assign an IP address. The storage team would come and assign storage to it. Then the system admins will come and install the database, packages, software, whatever it needs to be installed. And then the DBAs would get access to the database, and then they will install their tools, processes, and whatever they need to do. And then they'll give it to the application team to actually start using the application for deploying it. Once the app is deployed, then the operations team, the NOC, and the data BI team would start accessing the database, right? Making the reports. The BI team, the NOC will add some alerts. The operations team would start creating the alerts, and so on and so forth. So this was the workflow if I want to create an application that relies on a mission critical database. And only then I can give it to my customers. So this is the normal workflow. So what does it mean in a cloud world? We don't need support staff because I am not cabling anything. I'm not installing a hardware. I don't need a network team because AWS does all the networking, IP address assignment, everything in place, right? I don't need storage because, as you saw earlier, it's just, hey, Shane, please tell me if I'm running over time. And
No. Okay. Yeah.
Okay. So we don't need a storage team in the new scheme. We don't need a sysadmins because there's no patches, there's nothing to be installed. We may need some of the DBA work functionality, but not necessarily. The yellow X means we need a partial DBA. We obviously need an app team because their job hasn't changed. Ops team, maybe a little bit. NOC, maybe a little bit. And the BI team, we need it. So this is the scenario in one very simplified example that we see that your role, if you're a storage admin, if you're a network admin, if you're a security admin, sysadmin, how your job is getting impacted by this just one service I'm talking about. And remember, there are 200 plus services just in AWS alone. Okay, and that's the reason I want you guys to pay attention to these technologies. So final, any questions for you? I just have my last slide, final slot. And I like to close with this one. I recently found out about this one. So this is called the Choluteca Bridge. I don't know how to pronounce it, but this is a bridge that they constructed in Honduras, South America, right? And Honduras is apparently known for a lot of hurricanes. Um, and what they did was they built one of the strongest. They got some engineers from Japan. They designed a very strong bridge. And they, on that year, this is in like late 90s, on that year, within 3 or 4 months after building the bridge, there was a huge hurricane. Hurricane Mitch came up, and it brought about 75 inches worth of rain. And they usually get that much rain in a year. So it caused so much devastation that the road that was leading to the bridge on the left-hand side and the road that was going up the other side of the bridge were completely wiped. There's no road anymore. But the bridge is so strong that that's the only bridge in the country that survived, or in that area that survived. But the hurricane on the rain was so strong, the river, instead of flowing it underneath the bridge, it kind of started flowing right next to it. So this bridge is essentially doing nothing right now. It's an old relic. It has no purpose in life. So why am I sharing this story? Right? So this is what, the reason I'm sharing this story is because this is what happens to our careers if you're not careful, right? So we might think we are learning something useful, but life and nature has its own way of doing things. So tomorrow we might find ourselves in having built a bridge that nobody uses, right? This is bridge to nowhere. So the one thing I want you guys to take away from this presentation is there's always going to be change. This IT industry, especially if you're in IT industry, things have to look 2-3 years ahead of yourself and see what's coming down the industry. And then you guys are at a you're already on the path, but whether you become a cloud engineer or DevOps engineer or not, but at least keep an eye on what's coming in your industry and be prepared for what's coming, right? You don't want to be near the Choluteca Bridge. So that's all the slides I had.